Good afternoon, geometry. So this is the chapter 4 stuff we're doing right before Thanksgiving break. So I'd like to go over the first few here. We have to determine, you have 5 options as a shortcut. You have side, 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 angle, side, angle, angle, side, angle, side, angle, or hypotenuse, leg. Those are your 5 options. Show that 2 triangles are congruent. Again, these are shortcuts where once you know this information, just 3 pieces of information that are congruent, then you know all 6 parts of the triangle are congruent. Number 1, look at this top triangle here. I have an angle that's congruent. I have a total of 2 angles that are congruent. So automatically I know it's not side, 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 because that's just if all 3 sides are congruent. It's not side, angle, side, because that'd be if the angle between 2 sides is congruent. It's not that. It's not angle, angle, side, actually, because, again, my side is between my 2 angles, just like how in this ASA, the side S is between my 2 angles. Just like here in my picture of my triangle, my side is between my 2 angles. And it's not hypotenuse leg because you'd have to have a right triangle for that. So this is actually going to be angle, side, angle. Number 2, there's actually a few different options you have, which makes it a little tricky. But right now, without saying anything extra, hypotenuse leg. Remember, hypotenuse is the long side of the right triangle. It's across from the right triangle, or across from the right angle. I have a leg that are congruent, I have a pair of legs that are congruent, and a pair of hypotenuses that are congruent. So therefore, HL works. That's the quickest and easiest way. Now, as you guys know, if there's 2 triangles sharing a side, reflexive property makes sense. And now we could use side, 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 because all 3 sides are congruent from this triangle are congruent to this triangle. And then the last but not least, you actually could use side, angle, side, because I could say this side is congruent in both triangles. This angle that's between these 2 sides that are congruent, and so the 2 angles are congruent. So it's side, angle, side, or SAS. So you could use those 2, but hypotenuse leg would be the most intuitive. Next, same thing here. There's a couple different options. One, if I know that this is congruent to itself, I have 2 triangles sharing a side, I have side, side, side. So side, side, side is a great option. Works. Sounds good. If you did not think of that, if you did not think of those, that third side being congruent to itself, you could look at this little bow tie situation that we're talking about. This is vertical angles. So I know that this angle here, these 2 angles are congruent to each other, and these 2 angles are congruent to each other. And look at that. That means these 2 angles are congruent to each other. So now I have side, angle, side. So SAS also works. Whatever you want. Both are good to go. Number 4. This is that bow tie thing I was telling you guys about where you have a side, angle, side. Oh, I'm sorry, not side, angle, side. You just have vertical angles. So you have these 2 angles that are congruent. Now it's tricky. We have to go look at this. All right, it's not side, side, side because I don't have anything about the third side being congruent. Side, angle, side. It's close. I mean, I have a side, angle, side situation here, but if I do side, angle, angle there, it doesn't quite match up. So side, angle, side doesn't work. Angle, angle, side actually doesn't work out either. I have angle, angle, side over on this triangle, but here I have angle, side, angle. So that doesn't work. Is it angle, side, angle? Well, this triangle doesn't have an angle, side, angle situation. So that doesn't work either. Here's an angle, side, angle. But again, it's not matched up in this triangle here. And then hypotenuse leg. It's not a right triangle, so I can't use it. So it's actually none. It's close though. It's tricky. All right, and then 5. This one's easy and straightforward. That side's reflexive to itself by reflexive. So it's side, side, side. It shows the 2 triangles are congruent. Number 5. This one gets a lot of people, but it's always the same idea. These 2 remote interior angles add up to equal this exterior angle. So the reason being, if you want to think about it like this way, I'll give you a little proof. Angles in a triangle add up to 180. So if I wanted to find out what this third angle is here, I do 180 minus 15 minus 2x plus 3. And that would equal this angle x right here. not x, won't call x, we're all using x. We'll call it z. All right, so z is the same as this amount right here. And if I think about it from the 5x minus 60, this is a linear pair, so 180, so this is what z equals, and z also equals 180 minus 5x minus 60. Okay, so what happens is these two angles have to equal each other. Equals 180 minus 5x minus 60, and then you would go ahead the 180s, and then you can switch the signs and negatives, and you get 15 plus 2x plus 3 equals 5x minus 60. That was just background knowledge. All I really need you guys to do for tomorrow is just know that these two remote interior angles add up to equal this angle here. So this is number 6. So now that I did 15 plus 2x plus 3 equals 5x minus 60, I can just go ahead and solve for x. So 18 plus 2x is this. So I'm going to add 60 to both sides, so I get 78. I'll subtract 2x from both sides. So I get 78 equals 3x, or x equals, thought I had it in mind, 26. So x equals 26, and that's what number 6 asks for. Now, number 7, they want you to go ahead and find angle ABC. So this is ABC. When I say angle ABC, in this case, they're really just talking about angle B. B is my middle letter here. That's where the vertex is of the angle I'm talking about. So A to BC. So I'm just looking at the 2x plus 3, which I'm just going to go ahead and, this is what angle B equals. I'm going to go ahead and plug in 26 in for x. 2, so you get 55, right? Yep. So, got that, and that's number 7. Number 8, they want you to find angle BCD, which again is going to be from B down to C over to D. So they're talking about this 5x minus 60 question here. What is this angle measure? Well, I know x, so I'm going to go ahead and plug x in. And you get 70, which makes sense. I should get 70 because, as we said earlier, when I look up 15 plus what angle B is should add up to equal this other angle. Well, if this angle equals 55, which we found, so this would be 15 and this is 55, if we add those together, you get 70. So it adds up to this exterior angle here, which is what we were hoping for. All right, now you have 2 triangles. What's going on is I have a pair of angles congruent here. I have another pair of angles congruent here, which means by default, the third pair of angles have to be congruent. So I know that 4y squared has to equal 6y squared minus 40. All right, I'm going to solve for y squared just as I would solve for y. So let me subtract 6y squared from both sides. And negative 2y squared equals negative 40. I'll divide both sides by negative 2 and get y squared equals 20. Now, you can go ahead and take the square root of y, and that would be fine. Just tell me what y equals. But the thing is, the question actually in number 9, they want to know what y squared equals. So we just did that. We just found out that y squared equals 20. Number 10, it wants angle K, which is this angle up here. That's J. Well, that's J. To find angle K, I'm just going to plug 20 in for y squared. So it's going to be 4 times 20, which is 80. Number 11 is the same thing. They want angle J. So I'm going to plug 20 in for y. So 6 times 20 minus 40, which also equals 80. That's good. That means I did it right with all my algebra. It's good because my angles came out to be the same value. Alright, let's look at the proofs here. So I have this, you have to list the given information. So you have to list like AB is congruent to DE, and angle A is congruent to angle D. Now, as I said, whenever you have a bow tie thing going on here, all right, you're going to want to go ahead and use vertical angles. So I'm going to use vertical angles to show that these two angles are congruent. So I'll call it angle BCA is congruent to angle DCE. Vertical angles theorem. All right, now I have enough information to show that the two triangles are actually congruent. So I'm going to say triangle, I'm sorry, what are they trying to prove? Let me grab my review sheet here. Trying to prove triangle ABC is congruent to triangle DEC. And then again, I have to use one of my 5 shortcuts I listed earlier in the video. If you go around the triangle, it's going to be AAS. I have 2 angles and a side. Notice my side length that is congruent is not between my angles. So it's not ASA. So it is AAS. And we're done. Now I know everything else about these triangles are congruent. 13. Oh, look at this. They share a side. We're going to use reflexive property in this proof. So we're going to list the given information. And I'll just bring that on over here. Given. And actually, we're going to run out of space there, so let me move it back up here. You guys wish it was this easy to do on your little homework sheets. Alright, so now I got that. Now we start listing stuff. Alright, let's talk about, well, PN bisects MO. So this segment here cuts MO right in half, which means I know these two lengths are congruent. So MN is congruent to NO. Why? Well, they told us it bisects, so we have to use definition of bisects. Alright, 3, it says PN is perpendicular to MO. You know what? We'll get back to that in a minute. Let's do another one first. Alright, I want to say that this is reflexive. PN is congruent to itself. So side PN in one triangle is congruent to side PN in the other triangle. And that's reflexive. Alright, now let's list off, oh, PN is perpendicular to MO. Got that. Now what does that mean? Well, it means these are right angles. So I know angle MNP and angle ONP are right angles. Which is where this gets a little bit to be a tricky proof, to be honest. This is going to be the definition of perpendicular. Because these are right angles, you should have thought, hey, hypotenuse leg will work. The thing is, you should think of hypotenuse leg, but realize, hopefully, that this is my hypotenuse, because it's across from the right angle. This hypotenuse and this hypotenuse, I don't know if they're congruent. I don't know it. So I cannot say hypotenuse leg. But let's think about this. Aren't right angles have to be the same measure? All right angles are 90 degrees. So, and we've talked about this in class, so I can say angle MNP is congruent to angle ONP. Why? Because they're right angles, and we know right angles are congruent. The name of this theorem? Right angle congruence theorem. Just that right angles are congruent. And now, now we have enough information to say, hey, these are congruent, because if my right angles are congruent, I can think of this as a side angle side situation. The angle that's congruent is between two congruent sides. So triangle MNP is congruent to triangle ONP.